Hello guys, today we're going to be looking at the CH32X025. This is a 32-bit USB plus USB PD MCU from WCH, and we're going to be using this chip in particular to build our SnakeGame. Now, as you can see, it offers a lot of features and also a bunch of peripherals, and it comes in all sorts of packages. But today what I want to talk about in particular is some of the two main features. So the first one being its USB PD capabilities. So we're going to use the CH32X025 and its USB PD ranges in order to power up our board. And then the second feature is the PIOC. So we're also going to use the PIOC in this case to run the entire, to light up the LEDs without locking up the main thread of the main core. Okay guys, so this is the board we used for developing our system. As you can see, we have the 4 inputs here, and then over to the next side we have our power management, which in turn supplies power to the board and also controls the inputs for the WS2812 systems when we press one of the 4 buttons. Over here we have our USB, which has 2 functions: to power up the board via USPD or to program the MCU with a download link. Now if I zoom in a bit here, you can see the 2 functions of our USB. The first one being the USB PD, and we're going to use that USB PD to power up the entire board, and then as well, so 2 power up entry points, and then the data line for programming the WS2812, and then our 4 buttons for controlling the snake, and then lastly the flash system. So we need to press the download button before plugging in the USB PD. Okay, so in this episode we worked on the CH32X025 in order to create a SnakeGame. Now, the 2 most important pieces of the SnakeGame was the board controller, which was made using the RISC-V MCU, the CH32X025. It had 3 main functions: to power up the LED board using USB PD, download and flash the MCU, and also accept input from the buttons and control the snake. Now, for the LED screen, it was made up of WS2812 LEDs chained together. The system used 1024 LEDs in a 32x32 arrangement, and then we created an API to use as an XY 2-dimensional positional system in order to change and turn on each LED. So this is the WS2812 LED, and when it's chained together, you can see it at the bottom there, and also you can also see the PIOC interpretation of the code. Okay, let us look at some of the code for implementing the Snake program. So these are the 4 main functions we used for making the Snake program, and the key one first is the USB PD. As you can see, we can use a USB PD to request fixed voltage range all the way from 5 to 20 volts with a default of around 5 volts, with a default breakout of 5 volts. So this is how we power the board and all the LEDs. And then if we go back to main, the next one would be the RGB1W. This is for the LED programming for WS2812. So this is where we configure and enable the PIOC, peripheral, and also implement functions to program all of the lights. Now for the next part, this is the button configuration, the 4 buttons we used, and for the snake file, this is where we configured. This is where you find the configurations for the source. So for example, you can change certain variables like the speed you want the snake to move, and etc. And then here are the functions for implementing the snake, and also some initial declarations like the snake length at the beginning, and the direction or where the snake is going, and the body of the snake. So we can see that the snake has a maximum body size of 1024. So once you reach that length, if you can reach that length, then you would have finished the game. So that's the main functioning of the SnakeGame and the code we used to implement it. Okay, that's it. That's the end of this video. If you have any questions, please leave them in the comment section below. And you can reach out to us via email or on Twitter via Patrick Yang. That's it for this video. Goodbye.